When a transfer switch serves as the service equipment, the neutral conductor must be bonded to the enclosure. This bonding is accomplished at the grounding lug located inside the transfer switch enclosure. The number 6 grounding electrode conductor, often referred to as the GEC, should also be connected to the same grounding lug where the neutral is bonded. This ensures a proper grounding path for the system. Now, regarding the generator, there are a couple of different approaches depending on the type of transfer switch being used. If an automatic transfer switch is selected, it typically incorporates a mechanism to switch the generator neutral when the generator starts. This means that the neutral connection from the utility supply is disconnected and the generator's neutral is then connected to the system. On the other hand, if a manual transfer switch is used, the neutral is generally not switched. In this scenario, the neutral from the generator will likely need to be capped off within the transfer switch enclosure to prevent a parallel neutral path. A parallel neutral path can cause unwanted circulating currents and potential safety hazards. To summarize, firstly, bond the neutral to the enclosure at the grounding lug within the transfer switch enclosure. Secondly, connect the number 6 grounding electrode conductor to the same grounding lug where the neutral is bonded. Thirdly, consider the type of transfer switch being used, either automatic or manual, as it dictates whether the generator neutral is switched or needs to be capped off. When dealing with generators and transfer switches, it's critical to follow all applicable electrical codes and regulations such as the National Electrical Code, or NEC. These codes provide specific guidelines for grounding, bonding, and overcurrent protection to ensure a safe and reliable electrical system. The grounding electrode conductor, or GEC, plays a crucial role in providing a low impedance path to ground for fault currents. This path helps to facilitate the operation of overcurrent protective devices, such as circuit breakers or fuses, in the event of a ground fault. The size of the GEC is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. The GEC must be connected to a grounding electrode system, which typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes. The purpose of the grounding electrode system is to provide a connection to the earth, which helps to stabilize the voltage to ground and provide a path for fault currents to return to the source. When installing a transfer switch, it is important to carefully consider the location of the equipment and the available space. The transfer switch should be installed in a location that is readily accessible for maintenance and inspection. It should also be protected from physical damage and environmental conditions such as moisture and extreme temperatures. The wiring connections to the transfer switch must be made in accordance with the manufacturer's instructions and all applicable electrical codes. The conductors must be properly sized and insulated to prevent overheating and electrical shorts. The connections must be tight and secure to ensure reliable operation. Overcurrent protection is another important consideration when installing a transfer switch. The transfer switch must be protected by circuit breakers or fuses that are properly sized to protect the connected equipment and conductors. The overcurrent protective devices should be coordinated to ensure that the smallest overcurrent device trips first in the event of a fault. This helps to minimize the extent of the outage and prevent damage to the equipment. In addition to the grounding electrode conductor, there is also an equipment grounding conductor, or EG, which plays a role in grounding. The EGC is a conductor that connects the non-current carrying metal parts of electrical equipment to the grounding system. The purpose of the EGC is to provide a low impedance path for fault currents to return to the source, which helps to facilitate the operation of overcurrent protective devices. The EGC must be sized in accordance with NEC Table 250.122 and must be connected to the grounding bus in the service entrance panel. When a generator is connected to a transfer switch, it is important to consider the grounding and bonding requirements for the generator. The generator must be grounded in accordance with NEC Article 250. The specific grounding requirements for the generator depend on the type of generator and the application. In some cases, the generator may be required to be separately derived system, which means that it has its own grounding electrode system. In other cases, the generator may be permitted to be connected to the existing grounding system of the building. The neutral conductor of the generator must be bonded to the generator frame. The location of this bond depends on whether the generator is a separately derived system or not. If the generator is a separately derived system, the neutral must be bonded to the generator frame at the generator. If the generator is not a separately derived system, the neutral must be bonded to the generator frame at the service entrance panel. When installing a transfer switch, it is important to consider the voltage and current ratings of the equipment. The transfer switch must be rated for the voltage and current of the connected circuits. The conductors must be sized to carry the maximum current that the circuits are expected to draw. The overcurrent protective devices must be sized to protect the conductors and equipment from overloads and short circuits. It is also important to consider the ambient temperature when selecting and installing electrical equipment. The ambient temperature is the temperature of the air surrounding the equipment. The equipment must be rated for the ambient temperature in which it is installed. If the equipment is installed in a high ambient temperature environment, it may be necessary to derate the equipment to prevent overheating. When working with electrical equipment, it is important to follow all safety precautions. Always disconnect power before working on any electrical equipment. Use properly insulated tools and equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical equipment when you are wet or standing in water. If you are not qualified to work on electrical equipment, consult with a qualified electrician. The National Electrical Code, or NEC, is a comprehensive set of standards for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years and is adopted by many states and local jurisdictions. It is important to be familiar with the NEC when working with electrical equipment. The NEC contains specific requirements for grounding, bonding, overcurrent protection, wiring methods, and many other aspects of electrical installations. Failure to comply with the NEC can result in serious injury or death. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault currents to return to the source, which helps to facilitate the operation of overcurrent protective devices. Bonding connects the non-current carrying metal parts of electrical equipment to the grounding system, which helps to prevent electrical shock hazards. Overcurrent protection protects electrical equipment and conductors from overloads and short circuits. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. Wiring methods refer to the way in which electrical conductors are installed. The NEC specifies different wiring methods for different applications. Some common wiring methods include conduit, cable, and raceway. Each wiring method has its own advantages and disadvantages. Conduit is a rigid or flexible metal or plastic tubing that is used to protect electrical conductors. Cable is a factory assembly of 2 or more conductors that are enclosed in a sheath. Raceway is a metal or plastic channel that is used to support and protect electrical conductors. When installing electrical wiring, it is important to follow all of the requirements of the NEC. This will help to ensure a safe and reliable electrical system. In a context of generator installations and transfer switches, understanding the concepts of separately derived systems is crucial. A separately derived system is an electrical power source, such as a generator, that is not electrically connected to the building's main power source. When a generator is operated as a separately derived system, specific grounding requirements apply. The neutral conductor of the generator must be bonded to the generator frame at the generator itself. A grounding electrode conductor must also be connected from the generator frame to a grounding electrode, such as a ground rod. This creates a dedicated grounding system for the generator, independent of the building's grounding system. When a generator is not operated as a separately derived system, the neutral conductor is typically not bonded at the generator. Instead, the neutral conductor is bonded at the service entrance panel, where the building's main power source enters. In this case, the generator is connected to the building's existing grounding system. The choice of whether to operate a generator as a separately derived system or not depends on several factors, including the size of the generator, the type of load being served, and the requirements of the local electrical code. It is important to consult with a qualified electrician to determine the appropriate grounding method for a specific generator installation. In addition to the grounding requirements, there are also specific bonding requirements for generators and transfer switches. Bonding is the process of connecting the non-current carrying metal parts of electrical equipment together to create a low-impedance path for fault currents. This helps to prevent electrical shock hazards and ensures that overcurrent protective devices will operate properly in the event of a fault. The non-current carrying metal parts of a generator, such as the generator frame, the enclosure, and the conduit, must be bonded together. This can be accomplished by using bonding jumpers, which are short lengths of wire that are used to connect the metal parts together. The bonding jumpers must be sized in accordance with the NEC Table 250.100G. The non-current carrying metal parts of a transfer switch must also be bonded together. This can be accomplished by using bonding jumpers or by using a bonding bushing. A bonding bushing is a special type of fitting that is used to connect conduit to a metal enclosure. The bonding bushing has a sharp edge that penetrates the paint or other coating on the enclosure, providing a good electrical connection. When installing a transfer switch, it is important to ensure that the equipment is properly labeled. The label should indicate the voltage and current ratings of the equipment, as well as the type of transfer switch. The label should also include instructions for operating the transfer switch. The labeling requirements for transfer switches are specified in the NEC. In summary, proper grounding and bonding are essential for the safe and reliable operation of generators and transfer switches. It is important to follow all applicable electrical codes and regulations when installing this equipment. Consult with a qualified electrician if you have any questions or concerns. Always remember to disconnect power before working on any electrical equipment. Use properly insulated tools and equipment. Wear appropriate personal protective equipment. Never work on electrical equipment when you are wet or standing in water. Safety should always be your top priority when working with electricity.